Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be raising a complex number to the 7th power. So we have square root of 2 minus square root of 6 times I, and we're going to raise it to the 7th power. I'll be presenting two methods, but the first method will probably be incomplete, but let's take a look. Now, when you have to raise something to the 7th power, what are you thinking? Of course, the binomial theorem. So if your input is a plus bi, or a minus bi in this case, because I just chose a to be square root of 2 and b to be square root of 6, and if you plug it in, you're going to get our original expression to the 7th power. As you see, it is in expanded form, a really nice expression, isn't it? So you can go ahead and replace a with root 2, b with root 6, take care of all the powers, take care of powers of I, but it's already done for you, by the way, because whenever we have I to the 3rd power, that will be negative I. It's been taken care of, and you can just plug it in. But again, that's going to be a lot of work. So binomial theorem, even though it's a method, it's not the best one in my opinion. But again, you'll decide. So let's go ahead. This is the first method using the binomial theorem, and good luck with that. Now let's go ahead and talk about the second method. What does the second method involve? So we have square root of 2 minus square root of 6i, and we're going to raise it to the 7th power. Whenever you're given a problem like this, it could also be 2017th power. Obviously, you're not going to use the binomial theorem, are you? Well, if you do use it, that's going to take forever for sure. But anyways, here's what we're going to do. We're going to take advantage of a form called the polar form. So we're going to write this number using a little bit of trigonometry so that it's easier to raise to any power. So let's go ahead and do that. How do we do it? Whenever you're given a number like a plus bi or a minus bi, you can basically write it as r times e to the power I theta. Theta being the argument, r being the modulus. So this is called the modulus or the absolute value, and theta is called the argument, which is usually abbreviated with arg. Okay? Great. So how do you find those though? You just basically plot this as a point and then look at the angle. Easy, right? Using a little bit of trigonometry. You could also do the following. You could just divide the y by x. That's going to give you tangent theta. So in this case, tangent theta would be negative root 6 over root 2, which is negative root 3. But guess what? There are two angles whose tangent is negative root 3 between 0 and 2 pi. But you're going to decide by looking at the quadrant, which is given by the x and y values. So we have a positive x and a negative y here. Therefore, that would indicate the 4th quadrant, right? Think about it. X positive and y is negative. And notice that y is bigger if you don't consider the sign. So you're going to get something that looks like this. And the angle you're forming is actually going to be a 30, 60, 90 triangle, but this is going to be a 60-degree angle because that's the longer leg and this is the shorter leg. So you're basically talking about a 30, 60, 90 triangle, and the angle you're looking for is going to be measured like this. So it's just going to be 300 degrees, right? Or 5 pi over 3. So in this case, theta would be 5 pi over 3, which is equivalent to 300 degrees, right? Great. What about r? R is fairly easy to find. You're going to just square the real and imaginary parts and add them, and then take the square root. So it's going to be like this. The square root of root 2 squared plus negative root 6 squared, and then that's going to be 2 root 2. So we got everything we need, so why not cook it up, right? Let's go ahead and plug this in. So replace root 2 minus root 6i with 2 root 2 times e to the power I theta, which is 5 pi over 3. Make sense? Obviously, this is much better than the binomial theorem. This is a huge improvement. Now we're going to raise both sides to the 7th power. Let's go ahead and do it. 2 root 2 times e to the power 5 pi I over 3. Let me write it that way. And now we're going to raise it to the 7th power. And when we do raise it to the 7th power, you got to remember two things happen. The modulus is raised to the 7th power, so separately like this. 2 root 2 to the 7th power, and I'll show you how in a little bit. And then the angle is in the exponent, so it's just multiply by 7 because that's what the exponents rule say. So it's going to be 35 pi I over 3. We got to do a little bit of simplification here, but we can do it, no big deal. Let's go ahead and take care of the 2 root 2 to the 7th power first. So here's what I'm thinking. I'll take 2 root 2 and raise it to the 6th power, and then multiply it by itself so that it becomes the 7th power. But what is 2 root 2 to the 6th power? I'll just square the 2 root 2, and then, I said square, right? Not cube, and then cube it, and then multiply by 2 root 2. But if you square 2 root 2, you're going to get 8. So that's going to be 8 to the 3rd power times 2 root 2. But 8 to the 3rd power is the same as 2 to the 9th power, which is multiplied by 2 is going to give you 2 to the 10th power. In other words, this is going to be 1024 root 2. You could also find it this way. 2 to the 7th power is 128. Root 2 to the 7th power is, I think, let's see, 6 and 1. This is going to be 2 cubed, which is 8, 8 root 2. And then 8 times 128 is going to be 1024 again. So it's going to give you the same thing. So it's going to be like this. 1024 root 2. That's the modulus. But what about this angle here? 35 pi over 3 is pretty large. So let's go ahead and simplify 35 pi over 3. I need to take out multiples of 2 pi. So in other words, the numerator must be a multiple of 6. And the closest one would be 30 pi, because when you divide by 3, that's going to give you 10 pi, right? So we're going to write it as 30 pi plus 5 pi over 3, and this is going to be 10 pi plus 5 pi over 3. But guess what? 10 pi is 2 pi or 0. We can totally forget about it and just use 5 pi over 3. But wait a minute, wasn't that already 5 pi over 3? Yes, it was. It's the same thing. It just doesn't change. So the answer is 2 root 2 to the 7th power, which is 1024 root 2, times e to the power 5 pi over root 3 times I. And if you remember, it was the root 2 and root 6, but they're not the values that we're looking for. So we basically need to replace this with cosine of 5 pi over 3 and I times sine 5 pi over 3. Let's go ahead and replace the values. Now, if you think about it again, that's going to be like this, right? And the values are just going to be, in this case, negative root 3 over 2 and 1/2. Okay, makes sense? Because those are the original values if you scale it down. Okay, so what do? We just replace cosine 5 pi over 3 with the x value, which is 1/2, and sine 5 pi over 3 with negative root 3 over 2, but it's already negative, so let's just put a plus sign here. And when you multiply and distribute, you're going to get the following: 512 root 2 minus 512 root 3, and because the 2 is going to cancel out, actually that's not true, it's going to be root 6 over 2, so it's just going to be root 6 here because we already canceled out the 2 with this, and that's going to give you the answer in the standard form. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.